So this is my version of the 2014 maths. In the question, this is one where it will have the Na2CO3.X H2O. So this is not a primary standard because it has water of crystallization attached. In this question, as well as doing our W. So just to remind you, we will start with moles in 100,000 centimeters cubed of one of our reagents, our way in. When we go down, we always divide. So we divide by 1,000 to find out what's in 1 centimeter cubed. We then go up because we're following our path. So we will multiply by its titer volume. We then apply our ratio across the flat part. And from there, we work out how many moles of our other reagent we have in 1 centimeter cubed. And we do that by dividing by its titer volume. And then finally, to finish it off, we're going to multiply by 1,000 to find out how many moles in 1,000 centimeters cubed. We will be using our mass triangle to work out our grams per litre, and we have extra things which will be percentage water and the value of X in XH2O. So the first things that we do will be we have to write our data table, so we figure out what's in our basement, and over here is going to be the values for what's in our attic. And we know in our basement we're looking for a whole number that can be titrated. So if we read down through the question, it'll say a number of 25 centimeter cubed portions of this solution were titrated with 0.01 molar HCl. So that's told me that in my basement I'm putting my sodium carbonate. So when I titrate, I'm just titrating the sodium carbonate. I'm not titrating the water in there. That's just in my solution. In my attic then I must be putting the HCl. So I start filling my data table. So I have 25 centimeters cubed. I know that this is 0.1 big M. I'm looking for a titer volume for my HCl, so I'm finding that here, the 21.6. My ratio from the equation is 2, and for my sodium carbonate it is 1. This is my question mark, the thing I'm trying to find, and if I read down through my question here in D, find the concentration of sodium carbonate. So that is my question mark. There will also be an extra info part in our question that we're going to need. So we're looking for 2.5 grams that was made to 250. So that is my extra info. And I always personally will multiply this by 4 to turn it into grams in a litre. And the reason I'm doing that is when I do my titration grams per litre, I want the units to be comparable. So we start with our weigh in, which is over here. And the 0.1 big M just means 0.1 moles in 1,000 centimeters cubed. So I am at this point of my W up here. So the first thing I'm going to do is divide it by 1,000. When I divide it by 1,000, I get 1 by 10 to the minus 4 moles in a centimeter cubed. My calculator is giving it to me in scientific notation. If yours doesn't, you just write down whatever you're getting. Don't feel you have to change it. So that brings me to the first drop in my W. The next thing I'm going to do is multiply by the titer volume, which is the 21.6. And when I do that, I get 2.16 by 10 to the minus 3 moles, and that is in 21.6 centimeters cubed, and that's my first titer volume. So that has brought me to this part. So now I'm going to apply my ratio, and my ratio is 2 is to 1, and the 2 being 2.16 by 10 to the minus 3 moles. So I divide that by 2, multiply it by 1, and I find that I will have 1.08 by 10 to the minus 3 moles, and that is going to be in 25 centimeters cubed, and that is my other titer volume. So we're now across this part of our W. So we're going down now. So down is a division, and the division is going to be 1.08 by 10 to the minus 3 divided by 25. Now I don't have a calculator with me, so apologies for that. But my last step, if I had the answer to that, it would get me to this point. And my last step would be to multiply by that answer by 1,000. So if I do that, I'm going to get 0.0432 big M. Now, in my question here, there's 3 significant figures in 21.6, so that's why I'm having 3 significant figures down here with 0.0432. I still haven't read my question in terms of what it is I have to do, but our next step is always moles by molar mass. So 0.0432. This is my sodium carbonate, so it's going to be 23 by 2. It is 12 by 1, and it is 16 by 3. And when I add all those together, I get 106. And when I do that, I am going to get 4.58 grams in a litre. So I've said always get to this point, and then you go back and you read your question and you decide, can I annotate things? So up here in C, it's asking me for the number of moles of HCl per centimetre cubed. So this is going to be C part 1 here. It's asking me the number of moles in 21.6 centimetres cubed. So this is also going to be the second part to C part 2. It then asks find the concentration of sodium carbonate in moles per litre here. So that is this. So that is D part 1. And in D part 2, it asks to do it in grams per litre. So this is D part 2. Okay, I don't recommend rewriting out everything in case you make a mistake with your numbers. Just annotate, don't annotate, but as long as things are laid out in this kind of linear fashion, your examiner will be able to follow it for you. So the last part of our question here is asking us to calculate the percentage of water of crystallization in the crystals and the value of X. So this is how I set it up. Na2CO3.XH2O. So at the very beginning, we weighed out an amount, and our extra info was 10 grams in a litre. From our titration now, we have worked out we have 4.58 grams in a litre. And we find this by titration. To figure out the grams of water now, I'm just going to subtract the total from the titration value. So it's going to be 10 take away 4.58 grams, and when I do that, I am going to get 5.42 grams in a litre. So the mistake that candidates can make sometimes is instead of putting 10 grams here, they would leave this as 2.5 grams in 250, and then they're trying to do their maths and it doesn't work because the subtraction would be 2.5 take away 4.58. So I say go with it. If that's how you've done it, you will lose marks for this part here, but as long as you use the number correctly the rest of the way down, it'll be tick, tick, tick. Okay, so we need to figure out the percentage of water. So let me check this now. Perfect. So percentage of water is going to be your grams of water over your grams of total, and then obviously multiplied by 100 over 1. So when we do this, we have the 5.42, putting that over our 10 grams total. We're multiplying it by 100 over 1, and when we do that, we get 54.2%, which is 3 significant figures, which is our answer to the first part of E. Okay, the next part that we have to do is we have to work out the value of X in the XH2O. This is using the empirical formula method, and if you can remember what that was, we find our moles and we divide by the smallest number. When we did empirical formula, we would have been just using elements, but now we're going to be using compounds in which to do it. So we're going to put H2O here. So we put in what we have. We have 4.58 grams. We're going to divide that by 106. And when we do that, we end up with 0.0432. So this is essentially going backwards from our D part 2 to our D part 1. In terms of our water then, we are going to be going 5.42 H2O is 1 by 2 plus 16 is equal to 18. So that's going to be divided by 18. And when I do that, I'm going to get 0.303. So when I look at my two numbers, no, this one is wrong, apologies. It is 0.303. So when we look at these two numbers, this is the smallest number. So I'm going to divide both numbers by the smallest number. And if you think about it logically, I should only have one sodium carbonate. So I know I'm on the right track. And I'm going to go 0.303 by 0.0 divided by 40432. And when I do that, I get 6.9, and that's the equivalent of saying 1:7. So in this case, X is equal to 7. So if we had the pot of sodium carbonate, hydrated sodium carbonate, this is what we might see on it in terms of its molecular mass. But this is our answer.